Hello everyone, welcome to my video. In this video, we will deep dive into Android UI layouts. I am Subhash Gupta and today we will be breaking down the three musketeers of Android development, linear, relative and constraint layouts. This knowledge is essential for building fast, responsive and beautiful Android apps. Let's get started. Our agenda is straightforward. We will cover the view and view group basics that are required for the layouts and define what a layout is and we will compare the three main types we will look into some use cases and wrap this session with a practical demo and the conclusion. Android UI, view and view group basics, the building blocks of layout fundamentals. So what is a layout? Simply put, a layout defines the visual structure of your app's user interface. Think of it as a container that holds and arranges all your UI components like buttons and text boxes. Its key role is to ensure all your elements are sized, positioned, and displayed correctly, regardless of the screen size or orientation. We typically define these using XML files in the resources layout folder in the studio. As you see, it will be like as in the image. Why layouts matter in Android? Layouts matter because good design ensures responsiveness across all screen sizes. More importantly, a poor layout hierarchy, meaning deeply nested containers, can cause significant performance bottlenecks. Android gives us multiple layout types, so we can choose the best one for the job. Now let's see the building blocks of Android UI. Android UI is built on hierarchy of two core components, view and view group. A view is the smallest building block, often called a widget. It occupies a rectangular area and is responsible for drawing and event handling. Examples include text view and button. A view group is an invisible container, also known as a layout. It holds and structures other views or view groups. Examples are linear layout and constraint layout. Then how view and view groups include into this layout. The layout forms a tree structure hierarchy with a root view group at the top. Our goal for good design is to keep this hierarchy shallow and wide, meaning avoid excessive nesting. Deeply nested layouts hurt performance because the system has to perform multiple measure and layout passes to calculate the size and position of every component. As you see in the image, there is a root view group, and from it we can put another view group, two views. We using the second view group, we can derive three more views. Like this hierarchy goes on. So the layout is nothing but a combination of multiple views and view groups. There are some essential attributes that are required for the layouts. When defining a view or view group, four attributes are essential. As you see on the screen, we have layout width, layout height, layout margin, and padding. When it comes to layout width and layout height, they define the dimensions. Their key values are match parent, wrap content. Match parent, the view expands to fill its parent. In wrap content, the view shrinks just enough to enclose its content. And there is the third one. For fixed dimensions, we use DP, density independent pixels, for consistent sizing across different screens. When it comes to layout margin, it creates extra space outside the view's boundary. Then padding, it creates extra space inside the view between the boundary and its content. Now let's see about the layouts. The three musketeers of Android layouts, linear layout, relative layout, and constraint layout. Linear layout. The linear layout is the simplest. It arranges all its children in a single direction, either a single horizontal row or a single vertical column. Its key attribute is orientation, which can be horizontal or vertical. This layout comes with some pros and cons. Pro, it's simple and fast for basic sequential content. Con, creating complex UIs with it requires deep nesting, which as we discussed before is a bad for performance. It also uses the layout weight attribute to divide available space among its children based on ratio. For example, two buttons are there in this layout with layout weight 1. This will make the each button occupy 50% of the remaining space in the linear layout. Relative layout. The relative layout positions child views relative to each other or to the parent container. The positioning can be relative to parent, like aligning to parent's top, or relative to a sibling view, like placing view B to the right of view A. This layout also comes with pro and a con. The pro is it's much more flexible than linear layout and can achieve complex layouts with a flat single level hierarchy. The con is the positioning logic becomes very complex and hard to maintain in intricate designs. Crucially, relative layout has been largely deprecated in favor of constraint layout, which we will be discussing next. Constraint layout. The constraint layout is the modern standard and the recommended default for new Android projects. It's like the king of this era Android. The core idea is it's an incredibly flexible layout manager that positions and sizes the widgets based on constraints to other widgets or to the parent. The best benefit is it creates complex responsive UIs with an always flat view hierarchy, which results in the best performance. The key features include chains for grouping and styling the space distribution between the elements, guidelines for alignment, and bias to adjust a view's position between two constraint points. Now let's quickly compare all the layouts with each other under various features. Arrangement. Linear is sequential, relative is based on sibling or parent, and constraint is flexible on any axis. Hierarchy. Linear can be deeply nested, while relative and constraint are typically flat, with constraint being always flat for complexity. Performance. Linear is slow if nested, relative is medium, and constraint is the fastest and most performant, the winner of the performance race. Complexity. Linear is simple UI, performs, and toolbars. The relative layout, moderate to complex UIs. Constraint layout, it has all complex UIs. Space distribution, the linear layout is handled by layout weight, while relative layout has no native equal distribution. When it comes to constraint layout, it is handled by choice, spreaded, and weighted. When it comes to the recommendation, use linear layout only for very simple, strictly sequential UIs. Avoid relative layout for your new Android projects. Constraint layout is your primary choice for everything else. Now let's see a practical demo of these layouts. To see this in action, the next step is a practical demo where you would implement a simple user profile screen with a centered image, name below it, and two side-by-side buttons, using all three layouts to truly understand the differences between them in implementation. Let's see our first implementation. Our first attempt uses the linear layout. Since this layout can only arrange items in a single line, either horizontal or vertical, we must resort to nesting to achieve our side-by-side buttons. We start with the parent linear layout and set this orientation to vertical. This stacks the image, the name, and the button container vertically. We use Android Gravity equals center horizontal to center everything on the screen. Next, we define the profile image and name text view. They follow the vertical flow perfectly. The critical part is the buttons. To place follow and message side by side, we must introduce a nested linear layout and set its orientation to horizontal. You can observe that we succeeded in creating the UI, but at the cost of a deepened view hierarchy. This nesting can lead to performance issues, as the system must perform multiple measure and layout passes, which is why this approach is generally discouraged for complex UIs. Implementation is relative layout. The legacy approach, sibling and parent relationships. The relative layout allows us to create the same UI using a flat hierarchy, meaning only one parent container. However, it requires a lot of explicit positioning using reference IDs. We use the relative layout as a single root element. The profile image is positioned relative to the parent using Android layout underscore center horizontal equals true to center it. The name text view uses Android layout underscore below equals @ plus id image to position itself relative to the image's id and again uses layout underscore center horizontal. The two buttons rely on both parent and sibling relationships. Here we use an advanced technique for centering of the buttons, the invisible anchor view. This is the key innovation since we can't directly center two items side by side in relative layout. We introduce an invisible view element named center anchor. We set its width and height to 0 dp so it consumes no space. We place it precisely in the center of the screen using Android layout underscore center horizontal equals true. We ensure it's vertically positioned below the name using Android layout underscore below @ID / name text. Then we position the buttons relative to this invisible anchor point. The follow button uses Android layout underscore to start off equals @ID / center anchor to attach its right edge to the anchor's left edge. A negative margin end pushes it slightly left. The message button uses Android layout underscore to and off @ID center anchor to attach its left edge to the anchor's right edge. A positive margin start pushes it slightly right. Here you can observe that this approach successfully creates the complex side-by-side centered layout using a flat single level hierarchy. While clever, it still requires more intricate XML code and a clumsy dummy view compared to the simpler and more declarative constraint layout chains. Final implementation. Constraint layout implementation, the optimal approach, the modern efficient solution. Finally, we use the modern constraint layout. This is also a flat hierarchy, but uses a powerful system of constraints, which are like flexible rubber bands pulling the views into place. We use the constraint layout as a single root element, ensuring optimal performance. The profile image and name text view are easily positioned. To center the image horizontally, we constrain its start to the parent start and its end to the parent end. App layout underscore constraint start underscore to start of equals parent and app layout constraint end to underscore to end of equals parent. The name is constraint to the bottom of the image. App layout underscore constraint top underscore to bottom of equals @ plus id / profile image. For the side-by-side buttons, we use a powerful feature called chains. We link the two buttons together. Button 1's end to button 2's start and button 2 start to button 1's end. We constrain button 1's start to the parent start and button 2's end to the parent end. By setting the width to 0 dp or match constraint, and using app layout underscore constraint horizontal underscore weight equal to 1. On both, we create a weighted chain that automatically ensures equal width and distributes the buttons across the available space. Here we can observe that we achieved a complex responsive UI with a flat, high-performing hierarchy. The use of chains and weights makes the two-button arrangement clean and scalable, making constraint layout the recommended choice for all complex layouts. Now let's see the use cases of these layouts. There are various real-world applications for the layouts. Linear layout is great for simple navigation bars or basic vertical forms. Relative layout was historically used for complex screen headers or overlays. Constraint layout is used for everything from designing responsive app screens like social media feeds to optimizing performance in legacy apps by replacing nested layouts. Now let's conclude this session. To conclude, view is an element, widget, view group is a container, also layout. Always prefer a flat view hierarchy for optimal UI performance. Constraint layout is the modern standard, offering maximum flexibility and efficiency. Avoid relative layout in new development. Thank you for joining me in this video. I hope this presentation helps you build better and faster Android UIs using various layouts. Don't forget to like this video and subscribe for more content.